Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 8 Notes 1. So we're going to be talking about simplifying radical expressions. So first of all, we want to talk about finding the prime factorization of the number. So we're taking a number and we're breaking it down into primes. Then we're going to talk about simplifying a radical expression, which is going to use that same prime factorization idea, and then we're going to go ahead and we're going to add variables on top of it. So let's go ahead and let's take a look at what that's going to look like. So first and foremost, when we have 63, what we're going to do is we're going to break down 63 until we have all primes. So I want to ask myself, okay, what multiplies to 63? Well, that's going to be 9 and 7. Okay, so then I cannot break down 7 anymore. 7 is a prime number, so that leg is done. I can, however, break down 9. Now 9 breaks down to 3 and 3. So when we go through to write this out, what we're really doing is we are going to write out each of the ends of our legs. So 3, 3, 7. So the end of each of our legs. So that means that 3 times 7 multiplies to 63. Next, let's go ahead and take a look at 98. So I don't necessarily know what goes into 98, but I see that 98 is even. So because 98 is even, I can take 98 and divide it by 2. Well, when I divide it by 2, I get 49. So that tells me that 2 times 49 is going to multiply to 98. Well, 49 I can break down to 7 and 7. And as we discussed on the previous problem, 7 is a prime number. So then our prime factorization is 2 times 7 times 7. Next, let's go ahead and let's take a look at 180. So what multiplies to 180? Well, I see that it ends in a 0. So since it ends in a 0, it has to be divisible by 10. So what I did is I split it up by 18 and 10. 18 you can divide to 9 and 2. 10 you can divide down to 5 and 2. So we have all primes. 2 and 5 are both prime, but the 9 is not. So I'm going to take the 9 and I'm going to split it into 2. So then I like to write it out in numerical order. So I'm going to go at the ends of each of my legs. So I see that 2 and 2 are at the end, and then 3 and 3, and then 5. So this right here is the prime factorization for 180. All right, let's take a look at filling in these boxes. So for the first one, okay, so when you get to the radical expression, so any expression with a radical term. So when you have any expression with a radical term, that's going to be a radical expression. Next, simplified radical form of a radical expression. Okay, so when we fully simplified these radicals, there's no perfect squares left underneath the radical. There's no fractions underneath the radical, and there's no radicals in the denominator. So that's kind of our checklist of the 3 things we need to not have a radical in the denominator. Okay, so when you're simplifying radical expressions, what you're going to do is you're going to find the prime factorization of each number. That's what we did in problems 1 through 3. Then if there's a variable with a power, you want to write it in expanded form. Then what you're going to do is just find any pairs you have. If you have a pair, you can break out of the radical. So we're going to take a look at what that means, break out of the radical. So let's take a look at problem 50, or number 4. So when we break down 50, I want to think, okay, what divides 50? Well, 2 does. And I get 2 and 25. Well, what divides 25? Well, that's just going to be 5 and 5. So then underneath my radical, I'm going to put the ends of my legs. So I have a 2, I have a 5, and I have a 5. So then what I want to do is I want to locate my pairs. So what I notice here is that I have a pair of 5s. I've located that pair of 5s. So I'm going to take that pair of 5s and I'm going to bring it on out to the outside. So that pair of 5s is going to come to the outside. Then still left underneath the radical without a pair is that 2. Now what you'll notice is that when I broke this pair out of the radical, whenever you break out of the radical, you become 1. So because I took these pair of 5s out of the radical, it's just going to be written as 5. It's not going to be written as 5 times 5. It's just going to be written as 5. Then left underneath the radical, I have 2. So then I have 5 square root of 2. For our answer for number 4. Now let's take a look at 48. So what divides 48? Well, I know of 6 and 8, so I'm going to use that. So 6 and 8. And then I'm going to take 6 and 8, or 6, I'm going to divide into 2 and 3. And 8, I'm going to divide into 4 and 2. And for some reason, some students stop here. Okay, but 4 can still be divided, right? So we're going to take this 4, and we're going to divide it into 2 and 2. So now I'm going to take the ends of my legs right here, and I'm going to write that underneath the radical. So I have 2 times 2 times 2 times 2. So I have 4 2's, and I'm writing it in numerical order because that makes it really easy to find my pairs. So then I have a pair of 2's. Well, that pair of 2's is going to come out of the radical and become just a 2. Then I have another pair of 2's. Well, that pair of 2 is going to come out of the radical, and it's going to become just a 2. So I'm going to have 2 times 2 on the outside, and then left underneath the radical is the square root of 3. So what's 2 times 2? So whenever you take more than one pair outside of the radical, you're going to multiply them together. So we have 2 2's because we had 2 pairs of 2's. So 2 times 2 is 4, and then left underneath the radical is the square root of 3. So my answer to number 5 is 4 square root of 3. Now let's take a look at 32. So 32 I can divide up into being 4 and 8. 4 divides down to 2 and 2, and 4 divides down, or 8 divides down to 4 and 2. Last thing, divide that 4 down one more. So then I have the ends of each of my legs. So at the ends of each of my legs, I end up getting 5 different 2's. So I have 1, 2, 3, 4, and 5. So then we have 1 pair of 2's and 2 pair of 2's. So I can take that pair out, and I have 1 pair of 2's out, and I can take the next pair out, and I have 2. So I have 1, 2 pairs of 2's, and then left underneath the radical is the square root of 2. So I'm going to take and I'm going to multiply those out, and I get 4, and then that 1 2's left underneath the radical because it doesn't have a partner. That poor little 2 does not have a partner. Okay, let's take a look at some variables now. So now we're talking about variables. So when I have x to the 4th, what x to the 4th means is that underneath my radical, I have 4 x's. That's what x to the 4th means. So I have 1 pair of x's and I have 2 pairs of x's. So underneath the radical, I have x and x. So I'm going to take both of those out. So what I noticed is that everything underneath my radical ended up in a pair. So that means that I don't have anything left underneath my radical. So that means my radical is going to go away altogether. So I have 1 pair of x's and another pair of x's. So that's x times x. Well, what's x times x? You end up getting x squared. Okay, x times x is x squared. Let's take a look at number 8. So for number 8, I first want to break down that 4 into 2 and 2. So I'm going to go ahead and I'm going to write out my radical. So I'm going to have 2 2's, and then I'm going to have 3 b's because it's b cubed. So I have 1 pair of 2's that I could take out and 1 pair of b's that I can take out. So I'm going to take the 2 out, and then I have 2, and then I can take a pair of b's out. So I'm going to have a b on the outside. Now left underneath the radical without a pair is that poor lonely b. So that poor lonely b is going to stay in there. So then I have 2b square root of b for number 8. Now, taking a look at number 9, there's more parts, but it's really just going to be the same thing. So we're going to take 75, and we're going to do 25 and 3. And then we're going to take the 25, and we're going to split it into 5 and 5. So then I can go ahead and I can write things out underneath the radical. So I have 3 times 5 times 5. So I put out all my numbers, and then I have 2 x's, and I have 3 y's. So now I'm going to go ahead and find my pairs. So I have 1 pair of 5's, 1 pair of x's, and 1 pair of y's. So each of those pairs are going to come out as 1. So I'm going to have a 5 on the outside, I'm going to have an x on the outside, and I'm going to have a y on the outside. Then left underneath my radical, I still have a 3, and I also have a y left underneath my radical. So this right here is my final answer for number 9. Now let's take a look at simplifying radicals using perfect squares. So to determine the largest perfect square that divides a number, that's going to make this easier. Okay, it's thinking about what's the largest perfect square that goes into this number. Because here's the deal, once you have a pair, you can stop. If you want to keep, kind of breaking it on down, you always can, just like we did on those last couple of problems. But you could use that idea just to look for perfect squares. So then you're going to use the product property to rewrite the radical expression. And then you can take the square root to simplify. So basically the square root of AB is equal to the square root of A times the square root of B. So this idea doesn't really work as much with the variables. So to start off, let's give ourselves a good list of perfect squares. So then you have that, and I think that will help you to kind of recognize your perfect square. So let's go through and fill this out. And it'll just take me a second to get all these written in. So really, these are all the numbers that you're looking for. If you see these numbers, you're like, great, fantastic, this is a good thing because I know this number will help me. And we have 100, 121, 144, that is definitely a 2. 144, 169, 196, 225, 256, 289, 324. That did not work. This is too small for me. 361, and finally 400. So those are perfect squares that you can look for moving forward. So let's take a look at number 10. So I'm asking myself, okay, what perfect square divides 24? And I'm thinking, aha, 4. 4 will work. So I have 4 and I have 6. Okay, so I know 4 is going to break down to 2 and 2. Well, 6 isn't one of my perfect squares, so I know that 6 can't be broken down any further. So then I have 2 times 2 times 6, which makes sense, right? The square root of 2 is 2. So when I take that out of the radical, the square root of 2 is 2, and then left over is the square root of 6. Again, if this method is confusing to you, what we did previously on the note sheet will always still work. Okay, so 98. Can I get a perfect square out of 98? Well, remember when we did the prime factorization and I divided it by 2 and I got 49? Well, that makes me happy because 49 is a perfect square that I can divide into 7 and 7. So then left underneath the radical, we have 2 times 7 times 7. So because we have 2 7s from that 49, we can take that pair out. So I take that pair out and left underneath the radical is that 2. So the answer to number 11 then is 7 square root of 2. Now let's take a look at this one. So taking a look at 18. So I'm thinking about all the factors of 18. Now what factor of 18 is going to be a perfect square? Well, that's going to be 9. So I'm going to use 9 and 2 because 9 can break down to 3 and 3. So now we have this number on the outside of the radical. That's okay. We're still going to do the same thing. Then I have 2 times 3 times 3. So I have this pair of 3's that I'm going to take out. Now when I take it out, I need to multiply it by the coefficient that's already out there. So notice I multiplied it by that 3. And then left underneath the radical is 2. 3 times 3 is 9, and then you have the square root of 2. So 9 square root of 2. So then we're going to go ahead and we're going to split up the 12. So 12 I can divide down to being 4 and 3. And then I can split the 4 down to 2 and 2. So I have the 5 on the outside of the radical, and then I have 2 times 2 times 3. Well, I can take that pair of 2's out. When I take the pair of 2's out, I'm going to end up multiplying it by that 5 that's on the outside. 5 times 2 is 10, and then you get square root of 3. So we have 10 square root of 3. All right, let's take a look at this word problem here. It says a tsunami is fast moving an ocean wave caused by an undersea earthquake, landslide, or volcano. Scientists can predict arrival times, and so it gives us a model, and that's S is equal to the square root of GD. D is the depth in meters, and G is the 9.8 gravity constant of meters per second. So we'll need that for each problem. Okay, and so we want to figure out the speed of the tsunamis given certain pieces of information. So first of all, we're given the depth, and we want to figure out what the tsunami is going to be given that depth. Well, we're going to use the gravity constant of 9.8, and then we're going to go 100 meters deep. So our speed is going to be equal to our depth, which is 1,000, times our gravity constant, which from the original problem is 9.8. And that's going to be equal to the square root of 9,800. So now I want to go through and simplify that radical. So I want to simplify it down. So what I'm going to do is I see that it ends in 2 zeros. So I immediately know that 100 is going to be helpful to me. So I'm going to do 198. Well, 100 is one of my perfect squares, so that's going to already give me a pair. So I can take 100 and I can split 100 into 10 and 10. So now I already have a pair, so I'm going to stop there with the 100. I'm not going to simplify anymore. Now with 98, I remember that I can do 2 and 49, and then I have 7 and 7. So if we go and write this out all as one radical, I'm going to have the 2, and then I'm going to have 2 7s, and I'm going to have 2 9s. So I'm going to take out a pair of 7s and I'm going to take out a pair of 10s. So on the outside I'm going to have 7 times 10 and left underneath the radical is 2. 7 times 10 is 70 and then square root of 2. Now that represents the speed in meters per second. That was given to us, let's do this, per second. So the speed is 70 square root of 2 meters per second. So let's go ahead and let's take a look at part B. So now our ocean is going to be 4,000 meters deep. So just want you to note that it is 4 times the depth. So let's go ahead and let's calculate that out. So my speed is going to be equal to the square root of 4,000 times 9.8. So that's going to be the square root of 39,200. So let's go ahead and let's break that radical down, shall we? So when we break that radical down, we end up getting, I see that there's 2 zeros, so I'm going to use my 100 again. So I get 100 and I get 392. Well, I don't frankly know what divides 392, so I tried 4 because, hey, 4 is a perfect square, right? So I took 4 out and I ended up getting 98. Sweet, I know what to do with 98 now. 249, I get that perfect square, so I have my 7s. So now this one took a little while, and this 100 we can break down to 10 and 10, but here are the ends right here. 4 is a perfect square. That can be broken down to 2 and 2, so let's use that as our end instead. So then underneath our radical, when we multiply all of that out, we have 1, 2, 3 pairs of 2's from here, and then we have 1, 2 pairs of 7 and 2 pairs of 2 pairs of 10, 2 7s and 2 10s. So let's go ahead and we're going to circle our pair, circle our pair, circle our pair. So we're going to take a 2 out, we're going to take a 7 out, and we're going to take a 10 out. Then left underneath the radical is the square root of 2. So then 2 times 7 times 10 is 140, square root of 2, and then our label for speed is meters per second. So that's our final answer for part B. Now let's take a look lastly at this critical thinking piece for part C. Is the speed of tsunami that the water is 4,000 meters deep 4 times the speed of the one that is 1,000? Well, for 4,000 we got 140 times the square root of 2. For 1,000 we got 70 times the square root of 2. Well, it's definitely not 4,000 times it, right? In fact, it's 2 times the size of it. Well, why is that? Think about it logically. The depth is 4 times more. But when we did that 4 times more, we put it underneath a radical. What's the square root of 4? Well, it's 2. So that's why it's only double the speed because of that radical. So that concludes your note video for today. Please make sure you get that Schoology quiz taken. Thank you for listening.